In this video, I will introduce you to the basic rudiments of inequalities, and then we'll solve practice problems on linear inequalities. Now, let's say you have an algebraic inequality that looks like this. Okay, this is A is strictly less than B. A is strictly less than B, while B is strictly greater than A. The tip side of this sign is the less than this side, while this side is the greater than sign, is the greater than side. So the open side is greater than, that is B is greater than A, that is strictly greater than A. It is strictly greater than A because A is not close to B at all. If A is strictly less than B, it means that B is not close to A at all. That is, A and B are not close to each other. A is very, very less than B. It's just like saying 2 is strictly less than 20. Yes, 2 is strictly less than 20, but you can, however, say that 19.9 is not strictly less than 20. So you may say is less than or equal to 20 in that case. Now, let's say you want to represent A is strictly less than B on a number line. Okay, that will be, okay, let's say this is B, and then A is strictly less than B will be values of A. That means values of A are values that are not up to B. So we represent it in this manner, in this direction. Okay, in this direction. Notice that if we add A is less than or equal to B, if you want to represent this on a number line, so we'll have B, then the circle. Okay, now the difference will be that this side of the circle will be shaded, which indicates that B is also part of the region. Notice that in inequalities you consider regions of value, not an exact value. In inequality you consider the regions at which a value will exist. So A less than B, so these are the regions where A lies, including B for this part, but for this, these are the regions excluding B. So A lies in this region. Now, you may want to write the interval notation of this expression. To write the interval notation of this graph, okay? Now, notice that this is the negative infinity because it's the arrow tends to go towards the negative infinity, and this is the positive infinity. Okay, this is the same as the positive infinity, negative infinity. Notice that to write the interval notation for this particular problem, for this particular algebraic inequality, then that has to be minus infinity because it tends to minus infinity, comma, then point B. That is, it is between minus infinity and then point B. I use parentheses. Notice that this is called parentheses. This kind of bracket is parentheses. So use parentheses when you have infinity, but use this bracket, use this square bracket or bracket, use it when you have less than or equal to. For instance, in this case where I have negative infinity, anytime you have infinity, use the parentheses. So I will have negative infinity, comma, then B. Okay, since it includes B as well, so I need to use the square bracket or the bracket. Okay, now let's consider another example. Let's say you want to draw, let's have a linear inequality so we can represent the answer thereof. Okay, let's say we have 2x plus 5 less than 8. If 2x plus 5 is less than 8, then it means that 2x will be less than 8 minus 5. That is, if we subtract 5 from both sides of the inequality, so we can have something of this nature. 2x is less than 3, so it implies that x is less than 3 upon 2. Now, in order to represent this on a number line, notice that this is approximately 1.5 or thereabout. So in order to represent this on the number line, then I need to locate point 1.5. Let's say this is 1.5, then this has to be 2. Okay, then this should be 1, then this should be 0, then this should be minus 1. So I'm interested in 1.5, so we need to put a circle on it. Okay, now x is less than, notice that tip, x is less than, okay, notice this point. If x is less than 1.5, that means x exists in this region, because these are the region where values that are less than 1.5 lies. So that means x lie in this region excluding 1.5. Notice that this is the negative infinity and then this is 1.5. So in order to represent this with an interval notation, then that will be anytime you have infinity, make use of the parentheses and then comma 1.5. Okay, so if we had x is less than or equal to 1.5, notice that the interval notation will become minus infinity comma 1.5, then the square bracket. Now let's say you want to represent x is greater than or equal to 1.5. That's supposed to be 1.5. Then in this case, the arrow will move forward because these are the points, these are the values that are greater than 1.5. So x lies in this region. Notice that this is greater than or equal to, so this circle should be shaded. That means I'll have something of this nature: 1.5 comma then positive infinity, and anytime you use infinity, use the parentheses. Okay, notice that anytime you want to write the interval notation, you should always have the smaller part first before the bigger part. Let's talk about the compound inequality. A compound inequality is something of this nature: a less than b less than c. It is a compound inequality because it consists of two informations, two details, okay, which actually satisfies themselves. So let's say a is less than b and then b is less than c. Okay, now if you want to draw a less than b, then that will be, let's say that will be b less than, okay, so that will be in this direction. So don't forget this is negative infinity, so to represent this with the interval notation, that will be minus infinity comma b. Okay, in order to represent this as well, that will be b is less than c, so we need to find point c and then locate it. So that will be something of this nature. So where this is point c. All right, now but let's say we want to represent x greater than 7 and then less than or equal to minus 6. So you may read this in this case: a is less than b and b is less than c, or c is greater than b and b is greater than a. You may start at the middle: b is greater than, notice the open side of the sign, b is greater than a but b is less than c. Okay, so let's say you want to draw a number line for this. You will have something of this nature: x is greater than 7. So if x is greater than 7, that means if I have point 7 here and I have point negative 6, x greater than 7, that will be this point. So these are the values of x that are greater than 7. Notice that it also says that x is greater is less than, notice the tip, is less than or equal to negative 6. So these are the regions that are less than negative 6. So now the implication of this is that if x is greater than 7, that same x cannot be less than minus 6. Now, what does that imply? It means that this kind of compound inequality, you don't use and in when interpreting them. So you say x greater than 7 or x is less than or equal to minus 6, not x greater than 7 and x less than or equal to 6. Okay, let's represent this with the interval notation. Notice that this is the negative infinity and then this is the positive infinity. So in order to represent this, that's supposed to be minus infinity comma minus 6. Anytime I have infinity, I make use of the parentheses. Anytime I have, okay, this is just negative 6, and it is not equal, so I make use of parentheses as well. If I had equal, then I make use of the square bracket or the bracket. So this is supposed to be 7 comma positive infinity. So we can join them with union. So that's how to write the interval notation. You write for this, and then you join it with the union. This is the union sign. Okay, now let's say write you want to interpret something of this nature: x less than 7 but greater than or equal to minus 6. Okay, notice that this is minus 6, and then let this be 7. X less than 7, that's supposed to be in this manner, and then x greater than minus 6, greater than or equal. Oh, this is greater than or equal, so this should be shaded. Notice that this is the question: x less than or equal to, so less than in this direction, but because it has equal, I need to shade this line. Then if I shade it, the implication is it will affect the bracket. So the bracket has to be, it should be a bracket, okay, or a square bracket. So we will have something of this nature because it includes 6. All right, so if in this portion of the question x is greater than or equal to minus 6, so on minus 6 we'll have a shaded circle, and it will be directed towards the greater values of minus 6. So the implication is that the values of x lie in this region. So we can say that x is less than 7 and x is greater than or equal to minus 6. So if x lie in this region, it means that x is greater than 7 and x is also less than minus 6. Okay, just one value of x can do two things, but in this case one value of x cannot do two things. If a value of x is here, that same value cannot be here, and that's why we use the word or in this case. So this is how to represent this. Now, how do we represent this using the interval notation? The interval is between minus 6 and then 7, but 7 is not included, so we have this. Minus 6 is included, so we make use of this interval notation. All right, now let's say that you want to represent minus 6, okay, 7. So it will look like this, and then 7 as well will look like this. Okay, where this is negative 6 and this is 7. In that case, you will have minus 6 and 7 because they are all included. Okay, if you want to represent x less than 5 then greater than 3, that's supposed to be 3 and then 5. Okay, x less than 5, that's supposed to range in this direction. It will not be shaded because it does not include 5. It is strictly less than 5, and then it is strictly greater than 3, so it is in this manner. So we can say, however, that that is 3 comma 5. So we use the bracket because it does not include 3 and 5. Notice that it is impossible to have something of this nature: infinity comma 5. Okay, either this way or this way. But what I want to note is the infinity in this case. Notice that this infinity is bigger than 5. So there's nothing in this case. It will be incorrect to write the interval notation in this manner. You should either have negative infinity comma 5 or 5 comma infinity. The smaller ones comes first. Okay, so let's talk about some few properties of inequalities. If let's say you have inequality 2 less than 5, if you multiplied both sides of the inequality by fixed negative value, let's say you multiply by minus 5, the sign of the inequality would change. Okay, if I let's see that if I multiply by a negative value minus 5, that's supposed to be minus 10. Okay, and then this is supposed to be minus 25. According to the property says that the sign must change due to the multiplication of negative values. So we need to flip the inequalities. Now, so let's see if it is true, 2 is truly less than 5, and also minus 10 is truly greater than minus 25. So the property is valid. The same thing if you have an inequality, if you multiply true by a fixed positive value, let's say plus 5, the inequality sign remains the same. So if you multiply true, that's 10 less than 25, which is true. So the same thing if you had a fixed value to the inequality, let's say you had 5 to both sides, the inequality sign remains the same. So we have 7 less than 25, which is true. If you subtract a fixed value from the both sides of an inequality, let's say we subtract 5 from both sides, so that's supposed to be 2 minus 5. Let's okay, and then 5 minus 5, so that's supposed to be minus 3 and 0. So that means minus 3 is actually less than 0, so the sign remains the same. So if you subtract the same value, the same fixed value from an inequality, the sign remains the same. The sign only changes when you multiply both sides by a negative value, or if you divide both sides by a negative value. Now let's solve some problems. Find the range of values which will satisfy this inequality. All right, so this is some form of linear inequalities. So in order to do this, we may just add, okay, we may collect the like terms. The like terms are the one with x. Okay, so bringing 2x to this side will make 4x minus 2x, and then minus 3 greater than or equal to 3. That is, I subtracted 2x from both sides. Notice that 4x minus 2x, that's supposed to be 2x minus 3 greater than or equal to 3. So if I add 3x to both sides, then I'll have something of this nature: 2x greater than or equal to 6. Notice that I can divide both sides by 2, so that x is greater than or equal to 3. So we may represent this on a number line, okay, where this is point 3. If this is point 3, greater than or equal to means I'll also shade the circle, and then this is the trend for greater than values of 3. As a result, I can represent this. Notice that this is the positive infinity. In interval notation, then I'll have 3 comma this. Notice that it includes 3, so I will need to use this bracket. Anytime I have infinity, I make use of this bracket. Now let's solve another problem. Okay, so we have something of this nature. Okay, what do we do now? We should take 3h minus 3h to this side, so that we can have h on one side, so that will be okay. That means I'll be adding 3h to both sides. If I add 3h to both sides of the equation of the inequalities, then I'll have 5h minus half less than or equal to 4 half. Okay, so notice that 4 half is the same thing as 9 upon 2, so that I will have 5h minus 1 over 2 is greater than or equal to 9 upon 2, so that I will add half to both sides. If I add half to both sides, this will cancel out, so that I will have 5h is greater than or equal to, I just added half to both sides. This is 1 upon 2. So that was going to be 9 upon 2 plus half. So that 5h is greater than or equal to, that's supposed to be 10. Okay, and of course that's supposed to be 5. So that 5h is greater than or equal to 5. If I divide both sides of the inequality by 5, h will be greater than or equal to 1. So we can actually represent this on a number line. So h is greater than or equal, so because it includes 1 itself, so that's supposed to be 1 comma positive infinity. Okay.